Hello class, these are going to be the examples of sketching polynomials. Just quickly going over the features again. In factored form, the values of the factors match where the graph intersects the x-axis. The constant term, or you can find it using the multiplication of all of these, is going to be the y-intercept. And even degree polynomials start and end on the same side, whereas odd degree polynomials start and end on opposite sides. So using those ideas, let's actually sketch these. So here we go. Well, we can already see the y-intercept. It's going to be -15, so not to scale, let's just place it here. And now we can find the x-intercepts. Factoring this, two numbers I can think of are +3, -5. 1, 2, 3, 4, 5. So somewhat to scale, we can sketch it like so. You're definitely going to have to be a bit more careful than I am, because the iPad lets me use this feature where it makes parabolas for me. I'm just going to hack it a little bit, because definitely not to scale. -15, that's -3, +5, and that there is our sketch of the parabola. Moving right along. Once again, we can already see the y-intercept. It's going to be -8. Let's say it's just about there. And now we can factorize this. To make it easy, well, also because it has a negative lead coefficient, we know it's going to be concave down like so. So from this, we can factor out the negative. And we can factorize this once again. So negative, I can think of two numbers, -4 and -2. So that would mean the x-intercepts are at 2 and 4. So sketching this, actually, we can probably make this 100% accurate. 1, 2, 3, 4, 5, 6, 7, and 8 is actually right at the bottom there. So sketching this, we can actually make it symmetrical. That's 2 across, 2 across. And we can actually make this perfectly symmetrical. That is actually a perfect sketch of the parabola. So this is going to be at, whoop, that's not 4, that's going to be at 2, 4, and that point there is going to be -8. And there we have a sketch of these polynomials. So notice how we're using the x, or the factored form, to find the x-intercepts. We're using the y-intercept and the lead coefficient to determine if it's concave up or concave down. So let's keep moving forward. So from here, we can see what the y-intercept is. It has no constant term, so we know it's already going to go through the center here. We can figure this out further by factoring. Let's factor out a -x. This will become +x squared, +4x minus 12. Factoring this further, I can think of two numbers. I'll let you work it out for a moment. I can think of +6 and -2. So our x-intercepts are going to be 0, which is what we found here. -6, 1, 2, 3, 4, 5, 6. and positive 2. Whoops, that's 3. Positive 2. Okay, so now we're definitely going to have to use our features of a cubic. A positive lead coefficient of a cubic starts here and ends here. But because this is negative, it must start from here and end here. So from that, we can deduce that since it starts here and between these two x-intercepts, there must be a turning point. The graph must do something like this. Again, not 100% accurate, and we don't know how far down or how shallow it is. So since this is just a sketch, let's just leave it at here, because why not? And once again, so it's starting like this. So we've got the start of this, and remember, as we said, between these two x-intercepts, there must be a turning point. So it has to turn like this somehow. And it fulfills the odd degree nature. It starts here. It's going to end on the opposite side. Once again, this is definitely a sketch. This is not accurate. It's not 100% accurate. But we still get the general shape of this cubic. Let's put an arrow here as well. So let's do one more. You can pause and give this a go yourself. For this one, the constant term once again is 0. So we already know it's going to go through 0, 0. We can factor this, x outside of x squared minus 16. We can factor this further as the difference of 2 squares, plus 4 minus 4. And so from here we can make the following shape. So one x-intercept is going to be at negative 4. The other one is going to be on positive 4. Since this is a positive cubic, it starts in the bottom left and it should end here somewhere. And because we have two x-intercepts, it has to turn like this somehow in between. There must be a turning point. Come on. There must be a turning point in between the two somewhere. And actual fact, because of this symmetrical nature, it has to be perfectly symmetrical on the opposite side like this. And then from here, we can just finish off the rest. I'm just gonna, and there we go. Marking our intersects, 4, 0, positive 4. So I hope that gave you an insight into graphing polynomials using the x-intercepts and in factored form, as well as trying to find the y-intercept. Now, just need to emphasize this again. These turning points and how low or how high they are not accurate. What we're just generally looking for is the general shape of what these look like. Okay, so I'll see you in the next video where we go into more depth with this. Hope to see you then. Best of luck.